Alright, welcome to our next video in our circles unit. Today we'll be finding segment lengths in circles. Alright, the segments we're going to be talking about today that we're going to find the lengths of are going to be intersecting chords, intersecting secants, or intersecting tangents. The first thing we're going to look at is what happens when two chords intersect inside of a circle. And when two chords intersect inside of a circle, each chord is going to be divided up into two parts. So if I look at this chord right here, it's split up into A and B. And then this chord right here is split up into C and D. And what's going to happen is I'm going to take part 1 times part 2, so A times B. And that's going to equal, for my green chord, part 1 times part 2, or C times D. So in example 1 down here, we have two chords. We have LM and JK, and they're intersecting at point N, and we want to find the length of ML and JK. So if we take a look at ML first, we see that ML is broken up into LN and MN. And if I do part 1 times part 2, so part 1 would be LN, that would be x plus 3, times part 2 of that chord, which is going to be MN, or x plus 1. That's going to be equal to, for JK, we've got the two parts that are split up into JN and NK. JN is part 1, that'll be x plus 5, times part 2, which would be NK, which would just be x. Now on the left-hand side of the equation, I'm going to use the distributive property. I'm going to distribute x and 3 into my second binomial, so it's binomial times a binomial. X times x is going to give me x squared. X times 1 is going to give me 1x, or just x. 3 times x is going to give me 3x. And then 3 times 1 is going to give me 3. I'm going to use distributive property on the right-hand side as well. X times x is going to be x squared. And then x times 5 is going to be 5x. Now what we have is x squared is on both sides of the equation. So what I'm going to do is I'm going to subtract x squared from both sides. And what's going to happen is it's going to cancel out on both sides of my equation. It's going to leave me on the right-hand side with x and 3x are like terms. We can put those together as 4x plus 3, and that's going to be equal to 5x. We subtract 4x from both sides, and I'm going to get 5x minus 4x is 1x, or just x, and x equal to 3. Now if I go back and reread the problem and answer the question being asked, I want to find out what ML and JK are, which means I'm going to need to take x equals 3 and plug this into the different parts of the chord. So if I start up here with ML, x plus 3, so this is going to be 3 plus 3, which is going to be 6. And M is going to be 3 plus 1, which will be 4. So Ln is 6 and Mn is 4, so add this together, and you're going to get 10 for ML. For JK, you're going to add 3 plus 5, which is going to give me 8, and then NK is just going to be 3. So for JK, go ahead and add up 8 and 3, and you're going to get 11 for that one. So ML equals 10 and JK equals 11. Now the second possibility for intersecting segments is going to be if I have two secants. And if those secants are coming outside the circle, they're going to intersect at a point, in this case A, which is located outside of the circle. And in this case, what's going to happen is the outside part of this segment, which is AB, multiplied times the entire segment, secant segment, which is AC, is going to equal the outside part of my second one, which would be AD, times the entire thing, which would be AE. So AB, which is the outside part of the secant segment, times AC, which is the entire secant segment, is equal to AD, which is the outside part of the second secant segment, times AE, which is the entire second secant segment. Now example number 2 is going to go ahead and take this and we're going to explore what this would look like. And so we have two secant segments with an intersection outside of the circle. So what I'm going to do is I'm going to take the outside part, which is QR, or 6, And I'm going to multiply that times the entire secant segment, which is 4 plus 6, or 10. So that's the left-hand side of my equation. On the right-hand side, I'm going to explore the second secant segment, which would be RT, and the outside part of this would be 5, and I'm going to multiply that times the entire secant segment, which is going to be, the inside part is x, the outside part is 5. I'm going to add those together, so it's going to be x plus 5, and I'm going to go ahead and simplify. 6 times 10 is going to be 60. 5 times x is going to be 5x, and then 5 times 5 would be 25. We'll subtract 25 from both sides. And I'm going to get 35 equal to 5x. Divide both sides by 5, and x is going to equal 7. So go back and read the problem. I'm looking for what x is. We saw that x equals 7. Now we can go back and check my answer if I want to. So for the first part, we had 6, outside part times the entire thing. 6 times 10 equals 60. Now the blue part should be the exact same thing. Now that I know what x is, I can plug it in. X is 7. So it's going to be 5, which is the outside part, times the entire thing, which is 5 plus 7, or 12. And 5 times 12 is also 60. So these two numbers are the same, so let's just check my answer. I plugged it back in, and I got the exact same answer. All right, so go ahead and try the U-Try Nows, and if you have any questions, write them down, and ask them next time you see them. Have a good day.